So this video is going to show you how to use the crystal coloring routines in Crystal Grower. So here I have a net crystal setup. I'm looking at barite, which is an ionic crystal, barium sulfate. And I'm just going to grow a test crystal using some standard energy parameters and temperature parameters that I've been using. And you can see the energies I'm using there. And this is the tab I'm going to focus on, which is the crystal coloring tab. So this layer coloring, also called facet coloring, because we're talking about coloring the crystal facet. If you look at the logo on the left, that's an LTA crystal, which has been colored using the layer coloring routine. First of all, I'm going to run a simulation without layer coloring, so let's turn that off. We'll just run this simulation. And now that the simulation's finished, I'm going to visualize it in a veto. There is a separate video explaining in detail how to use a veto. So I'll just open the simulation here. And now I need to choose my column mapping. So I'm currently using column 3. That's actually important for layer coloring. Since I have layer coloring turned off, that column's only going to be filled with 1. So we can try and visualize it and you'll see the result. You just see everything's colored the same. So if I edit my column mapping, so if I go to column 2 instead, and I'll change that to particle type, press OK, you can see that it's now colored by type. So column 2 is particle number. That will show units that are the same type, but they're in different positions. So there'll be a lot more colors in this. So if we then edit mapping again, and we choose column 1 instead, we'll set this as particle type as well. Now you can see we've only got 2 colors. So one will be the barium, and one will be the sulfate here. But we've got some nice layers on our surface, so is there a way that we can color them based off the facets that are being shown? And yes, we can. We can use the layer coloring routine in Crystal Grower, which will automatically try and locate which facets are shown in your crystal and color them accordingly. So let's go back to our simulation. And this time we'll say yes to layer coloring. And we haven't run a layer coloring simulation before, so we'll select the option find this time. This is the automatic detection routine, so this will try and find all the layers that we saw in that crystal that we just visualized. So we'll leave everything else the same, but we'll just set it to find this time. We'll run the simulation. So let's visualize this simulation and see how the third column changes. So we'll open the newest simulation we've run in a veto. And we'll pick column 3, not column 1. Because column 1 and 2 will stay the same. Column 3 is the only one that changes. So you can see now, instead of having everything colored the same, we've got some layer coloring or facet coloring. But there's a few errors. You can see there's too many layers being colored on the top as one color. We want to ideally separate these into individual layers. And maybe we can see what we can do about the sides as well. And you can see this side is also missing, this side is missing, and that side's missing. So we need to have a look to see which facets it's found and which ones it's missed. And we can do all this within the Crystal Grower user interface. So let's go back to that last page. So this part of the page down here, this is where you can start editing your crystal file. We want to edit the file that was generated when we ran in find mode. Find mode will generate a file which contains all the facets that Crystal Grower is located in the crystal. So let's try and find that file. So it'll be in the simulation we ran just now, which was this bottom one here. And there'll be a file called Facets Found. We'll open that. And we can read it in. So you can see it's identified quite a few facets. It's identified the 004 set, the 003 set, and the 002 and 001 set. These planes are all in the same direction, but the spacing between them are slightly different. So the 002 planes are halfway between the 001 planes. So we know for a start that we don't need multiple planes along the same direction. So that's one way that we can cut down the number of planes that we're showing. So in the visualization we saw that 2 layers were being colored the same color. So this highlights to us that the 001 planes might be too large. So we might need to look at planes which are halfway between those. So we'll keep the 002, but then we don't need the 003 and the 004 set. So we can get rid of those. So we've cut down to 4 facets, but we know there's more. We know there's about 6. When you look at that crystal morphology, we had 2 large faces, and then we had 4 side smaller faces. We'll try adding new facets in the next step. First of all, we need to save the file that we've now edited. So let's find a place to save it. I'll put it in the top level folder for Barite, and I'll call it Barite Facets Edited.txt. I'll press Save Changes. Now I want to run a simulation where I use the facet file that we just changed as an input to tell the simulation which facets to color. So we need to switch to color mode. So that now opens a prompt where you have to tell Crystal Grower where that file is. So in this case, we will go and look for this one here. So we'll read that in. So there's 2 options here. We can either run a whole new simulation, which will grow a crystal from scratch, or we can use a checkpoint, which would allow us to read in that last simulation we ran, but color it slightly differently. So I'm going to opt for the latter because we don't want to grow a crystal which is slightly different shape. We want to stick with the exact same crystal we just had, because all we're doing is recoloring. So we need to go back and change a few options in our simulation. The checkpointing routine is discussed in greater detail in another video. I'm just going to use this as a quick example. So we're going to read in the checkpoint of the last simulation we ran. So that's going to keep that crystal that we just grew. And then we're going to make the number of iterations very short. We're going to set it to 2 iterations because we don't want to have to regrow an entire crystal. 2 is the smallest number of iterations we can run without crashing the simulation. So we'll just run 2 steps. The crystal will barely change at all, but the recoloring will all be done by Crystal Grower. So we can skip right back to the end now and just run this simulation. And you can see it quickly completes the simulation and spits out the new file. So let's visualize that simulation we just completed. We'll go to our newest one and we'll open the XYZ file in Avito. And we'll use the same column mapping. So you can see now the facets tidied up a lot more on the top. And the bottom facets too. You can see the layers are colored correctly. If we compare this to our previous simulation, you can see it's not doing the same thing as it was previously where it's coloring 2 layers at once. But we do still have some missing facets. The same ones that were missing in the previous simulation. So this is the new one. You can see we've got a facet there and there. But we don't have the other corresponding facets. So we need to add these into our edited facets file. We can do that by running another simulation. We can read in that first simulation as a checkpoint again and just carry on making some adjustments to the facets file. So we know we need to add some facets in. So let's open our edited file and add these new facets. So we can see this now has our 4 facets that we used for that coloring routine just now. Let's try adding in some new facets. We can use this box here to load a file which contains information about all the facets in Barite. So if we click Browse and we go to the simulation where we ran the find routine, you can see we've got a facets all file. So if we load that in, say add missing plane, we can choose the index that we're going to add in. So for example, it's odd that we have the -210 and the 2 -10, but we don't have the 210 and -2 -10 because they should have the same D spacing in the structure. So if we type that in, 210, we can say add plane. So you can see it's now showing us the 210 plane, which is extracted from that file. And it's given us the D spacing, which matches the -210 facet here. But we also want the corresponding negative plane. So you can either just type in -2 -10 and add the plane, or you can click add planes with equal D spacing, and you can see now that it's picked up the -2 -10 plane with the same D spacing. So we can now click confirm and close window, and that will now add those 2 extra planes to our list. And this list is always sorted by despacing. So let's click Save Changes, which is going to overwrite our previous Facets edited file, and we can press Run Crystal Grower again. So this completes very quickly. Now we can open this simulation in Avito. So now we can see that all the facets are colored. We've got the extra 2 facets on the side that were missing previously. But you can see that there's not enough layers on these facets to color the whole facet correctly. So we've got 1, 2, 3, 4, 5 layers there. And then we've got 1, 2, 3, 4. You can see 4 layers down there. And 4 on each of these side facets. So we probably need to add a few more layers, especially on the bottom facet, and maybe on the side as well. There's a lot of small nucleations on this side, so it's quite difficult to see how many exactly we'd need, but we definitely need more than 4. So we can make all these changes in the user interface too, so let's go back to the user interface. Because I'm happy with the facets that have been chosen, I'm going to keep that as a backup file, and I'm going to make a new file where I change the number of layers. So I'll click Save Changes there. And I know that all the side facets need quite a few more layers, so I'll double these to 8. And I know that the bottom facet needs more layers than the top facet does, so I'll put that one to 8. And I'll set the top one to 6. So I know which one of these is which because of the direction of the plane. So the 0, 0, -2 will be the bottom one, and the 0, 0, 2 will be the top. Based on the direction, they'll cut across the crystal in the C direction. So I'll need to save the changes I've made, but then also change the facets file that we're reading for the coloring. So that's going to be edited_2 now. And then I can run the simulation. And then we can visualize this in Avito and see if the coloring's any better. And there you can see the coloring's a lot better. Top facet's pretty much fully colored. And then the bottom facet could probably do with one more layer. So we'll bump that up to 9 to get the coloring perfect. So there's one other parameter you can change with the layer coloring, which is the offset. So we go back to the user interface, this box here. So the offset is designed for when you've got the right spacing of your planes, but it needs to be shifted up or down slightly. So say for example, some ions in your structure aren't in a perfect line. They might get picked up as being part of the layer underneath, even though they are part of a terrace above. So you'll be able to tell that this is happening when your terrace coloring doesn't look right. So if it's kind of patchy with 2 different colors mixed into it. So that means it's picking up 2 things that are part of the same terrace as 2 separate layers. So you sometimes need to shift the spacing up or down. The spacing will stay consistent, so it'll still be the 0, 0, 2 or whatever plane you have set. You're just moving the slice up or down slightly to make sure it's catching the right units in the correct layers. So I'll change the number of layers here to 9, because we saw we needed an extra layer on the bottom plane. And let's try changing some of the offsets on these side facets just to see what happens. So let's change this to 0.1, and we'll change this one to 0.1 as well. See if we can see any difference. We'll save this as a 3rd facets file. And save the changes, and then change the file that we're going to read from. We can run Crystal Grower again. And then visualize in Avito. So you can see the bottom face, we've added in that extra layer, so it's looking a bit better. But you can see on this facet here, maybe this strip here, if I zoom in, you can see these should probably be the same layer, but they're being mixed in together. So you've got some purple units mixed in with some red units, even though they should probably be in the same layer. And you can see some purples mixing in with the yellow down here. and that's because we've changed the offset. So if we change it back and rerun the simulation, we should get rid of that. And that shows you a bit of how the offset works. So we'll go back to our user interface. We'll change this back to minus 0.01 and see if that tidies up the coloring. We won't create a new file here because we're just making some very small changes. So let's visualize that again in a veto. See if it gets rid of that artifact. So if we zoom in, move on to the other facets, you can see there's some bits of it that are still there. So maybe we were changing the offset on a different facet. So let's try changing the offset for other facets that are in the same family. So we originally changed the bottom two here, the -2, -1, 0. Let's try changing these two up the top. So let's change that to 0.2 or something, just a large number, just to see if we can get a difference to happen. Save changes and run the simulation again. Visualize in a veto. See that facet's looking a little bit better. This one is definitely looking better. You can see that the layers are nicely separated now. If we compare this with the previous simulation, you can see everything was kind of mixed together, but now in this simulation, everything's separated nicely into layers. So I hope this has shown you in detail how to use the layer coloring routine in Crystal Grower. It's essential to get your crystal coloring correct because it makes it a lot easier to spot features in the surface topology, which let you know if you've got your energies correct when you compare with in situ atomic force microscopy. And it also generally just makes your simulation images look a lot better. Once you've got it correct for a crystal structure and a certain crystal morphology, you can use this file with every simulation that gives you the same morphology, so you don't have to do this every single time. But it's good to know how to tweak it slightly, like the number of layers, for example, might change between simulations. Because Crystal Grower is a Monte Carlo tool, so even if you put the same parameters in, you're not going to get the exact same result every time. So most of the file will be the same planes will appear, but you might have to tweak the layers slightly. The offset will also be correct once you've got it for one of the crystal morphologies, you won't have to change that. If you want more information on the checkpointing process used in the simulation, have a look at the dedicated video for checkpointing in Crystal Grower.